Hello everyone, welcome back to our Software Engineering and Unified Modeling lecture series. I am Nadia Patel. So we are in continuation to Unified Modeling Language Diagrams Part 2 and Introduction to Software Testing. So from today's lecture or onwards we will study what exactly software testing is. If you are a computer student, you might be familiar to what exactly testing is, who testers are, but in this small series we will actually go through how exactly the process of testing takes place, what testing is, and are developers, coders, testers different, same, who is responsible for the quality of software at the end. We will understand and go through every single part of it. So let's get started with our today's lecture, that is software testing. So points we will try to cover in today's lecture are introduction about testing, what exactly verification is and what exactly validation is. We will try to coin a proper definition for testing. We will go through need of testing. Why is it so important, or is it really of that importance? We will check benefits of testing, and finally who performs testing. So we are going to take an overview of testing, like how exactly testing works, because if you ask me, when we are trying to get jobs in software industry, which has become the most elite industry of society right now, the most dependable jobs, you can say. So if you have cleared your aptitude, you have cleared your technical rounds, and you are into your PI rounds, which is the personal interview round, this is the part where you will actually find at least one question coming on to you from your interviewer to check exactly do you know what testing is. They might ask you definition, or they might actually, I have also gone through some people who have started their career as testers. So it is said that you can get a job of testing after you go through certain phases, or when you perform some set of roles, like you become the designer, you become the developer, you get into the coding thing, and then you get the job of testing. Some say it is the most, I think you can say the important one. Some say it is the most difficult one. Some say if you want to stay in this industry, coding is the thing where you can have a dependable career. But some say if you are pro, or you are having those skills inside you, you can get a good job, that is a testing job. So all of these are part and parcels of software development. As a developer, you should understand every phase, you should understand every part of work. Again, if you are in a hurry and you just want to recall and recap all of what you have studied till now, this lecture series could actually help you to get some points in your head before going and approaching a company. So before interview, if you want to go through and prepare, you can go through these series. So let's get started. We have already seen SDLC, which is System Development Lifecycle. You have already gone through maybe from process models. So when you went through these phases, you might have seen a separate dedicated phase of testing and integration. It gets started with planning and requirement analysis, you have system analysis, you have design and develop phase, then you have testing and integration, further you have implementation, and finally maintenance. While speaking about diagrams and theories, if you check, after testing and integration, there is phase of implementation, that is installation. This is where you actually implement your software. And finally, you have the phase of maintenance. But if you check in here, this is not simply just a phase or when you see the diagram, you might feel that every phase is treated equally and is of equal duration of time. But it is not the case when it comes to practicality or when it comes to practical application. Here you actually perform a small iteration. The team of testing or the team of testing and integration will check the developer's work. They will verify, they will validate it. If they think there are certain issues or there are certain problems in the developed product, they might return the product back in the developing environment. They might also expect you to remove those anomalies, to remove those unwanted parts, get it done from you and again test it. This is a small iteration if you ask. So until and unless the testing team is satisfied with the developers and coding team's work and they have a good conversation and good interaction with customer and customer accepts your product, only then you are going to jump out of this phase. Otherwise you are going to remain into this phase and this iteration is going to take a long period of time. So as we all know, every team is supposed to perform their work correctly. If the planning and requirement analysis team have some problems in gathering the requirements, it is definitely going to reflect in the system analysis. It is definitely going to reflect in the design and develop phase, and this is going to hamper and going to take a lot of time. So while we study theory, we just go through diagrams, we go through phases, but when it comes to actual implementation and practical, you can say working, it is very different. So many of industry people actually don't agree to what we study, like this is not the thing. They might question you in your interviews that what have you studied, this is not the thing, this doesn't happen. But these are the terms of theory and this is theoretical. While putting into practice, things actually change. Now let us head and check one process model which is evolved from SDLC, because as we all know, SDLC is a model which gets applied to any development. So if you want to develop anything, not only software, you can rely on SDLC. This model is going to help you a lot. One process model evolved from SDLC and the most popular one which is still into practice, many people, many companies still follow the model which is software model of development, which is waterfall model. But as we all know, one big drawback of waterfall model is that, and you can say one big rule of waterfall model is that you cannot jump back to the previous phase. So this model only suits to the projects where requirements are going to be fixed in the first phase itself, where requirements are going to rarely change and there will not be any changes in design, there will not be any changes in coding, and then there will be testing. So again, if you ask any industry person that do you really follow and work with waterfall model, they might laugh at you, because now the industry has gained standards. Softwares have become products now. It has got a market. It has got a wide range of people. It has evolved, we can say, from customer to user, from user to end users. So they might actually have a difference of opinion. But this was again theory to study. So our aim is to actually make sure what exactly these terms are, what exactly these phases are. And now we will actually go through the phase of testing. We will cut down this phase and I'm trying to keep it very, very simple for you. So after performing the phase of testing, you will be installing your product and then it will come into practice. So these were the model, and by far every process model has one phase of testing. So let us take a quick introduction about what testing is. Testing is the process of executing a program with the aim of finding defects. So here we are going to find defects. Now again, there are debate on using proper terms in testing. Some people make use of term error, some make use of failure, some make use of you can say flaws. So there are certain set of terms which I will try to put up in the next working lecture. I'll just try to just get through what more added terms we can use. But by far defect is the term which gets probably commonly used. So one thing is that testing is process of executing a program with the aim of finding defect. If testing is done successfully, it will remove all the defects from the software. Softwares are tested against the good quality software attributes. Those are reliable, scalable, portable, reusable and usable. I've already uploaded a video on characteristics of software. You can go through it and actually know what exactly these terms mean. So we are not simply going to sit and check what input should I give and what output the product is giving. We need to make it very clear that software has going to be getting a market now. So it has to be reliable, it has to be scalable, it has to be portable, it should be usable and reusable. It has gained a market, it has gained a standard now, and we should follow all of the, we can say, rules. So these are the terms which you should never forget. Evaluation of the software against requirements gathered from users and system specification. We are going to evaluate. Evaluating is separating or cutting down things and checking them against system specifications. Process of evaluation of a software to detect the difference between given input and expected output. So is there any deviation? So what exactly is deviation? That means, say for example, you are supposed to perform addition. If you are performing 2 plus 2, it should give you the result of 4. But if your output is, if you are getting output 3.9, that means there is a deviation of 0.1. So we need to check, are there any deviations in our outputs? So how we will understand all of these things? We can only understand when we get some set of inputs, when we come up with some test cases. Then we can sit and evaluate any software. Software's features are determined here. What features are your software having? You can just check in this phase. Testing further performs two activities. One is verification and the other is validation. Now let us understand what exactly the activity of verification is all about. Because again, as I told you, testing is not a process of 1 day or 2 days. It is not a job of 1 person or 2 person. A separate dedicated team works on the developed product, or you can say developed software. It checks for every loop and every corner, and it is again a time consuming process. If your previous teams have not done their work satisfactorily, testing is going to take a very long time and again incur a lot of cost, because testing requires testing is actually an expensive kind of phase as well. So verification, let us go through. If you check the meaning of word verifying or verification, that means we are checking whether something is real, whether something is true, whether something is accurate or not. So how do we understand that whether the thing which we are verifying is real, is true or accurate or not? We need to compare it with something. Only then we can understand whether the thing which we are checking is true, is real or not. So how do we compare software, and with what should we compare our software? Verification is checking whether the software meets the specification or not. Now, what exactly is specification? Specifications are a set of documents where you specify everything. So, right from your first phase of requirement analysis and gathering to your design and develop, you collect information, you specify them in a certain format, in a fixed format with some proper headings and proper writing. There shouldn't be a vague essay. You are not supposed to sit and write a history or a story of what exactly happened. You are supposed to pick particular terms, specify them in particular lines, and this document popularly in softwares are known as SRS, which is System Requirement Specification Document or Software Requirement Specification Document. It contains everything. It is soul of your development. So right from the first phase till the last phase, you are going to specify every single thing. Even whatever customer has given in the form of needs is specified in this document. So further, verification in software testing is a process of checking documents, design, code, and program. This activity is performed to ensure the quality of software application, design, and architecture. The verification process involves smaller activities like reviews, walkthroughs, and inspection. One real-life example of verification could be the process of document verification for passport. If you have applied for passport, a process of document verification takes place where actually your documents are verified, your address is verified, you as a person is true, you as a person is real or not is checked. There can be a process, or you can say a phase where policeman can come and actually have a conversation with your neighbors to check whether you stay in the proper address or not. So this is verification, where exactly your address or you as a person, your identity is verified. Similarly, this happens with the help of document. So our software's verification is also going to take place with the help of a specification, that is SRS. Now let us go through what exactly validation means. Again, if you check the meaning of this term, validation or validating means correcting. You are correcting something. In the previous phase, you verified whether the developed software is against, or you compared it with the SRS. Now in this activity, you are going to correct. If you found something to be incorrect, you will be correcting it. If the software product actually meets the exact needs of customer or not, we will now focus only on customers' needs. Whatever they are expecting from you and your product will be checked in this activity. The validation process involves activities like unit testing, integration testing, system testing, user acceptance testing. So in coming lectures, we will elaborate every single smaller type of testing. But we have already gone through unit testing, integration testing, system testing, and user acceptance testing in waterfall model. If you have forgotten, please kindly go and review the previous video. Now let us coin a formal definition for testing. It is a process used to identify the correctness, completeness, and quality of the developed computer software. It includes set of activities conducted with the intention of finding errors, gaps, or missing requirements from software. This can be done either manually or with the help of software tools before delivering it to end users. If you are performing the phase of testing manually, it is known as manual testing. If you're making use of any software tools, it is known as automation testing. So why testing is performed, or what is the need of testing? to detect situation of failures of a system so that we can avoid them. Now again you will sit and have a difference of opinion that if the developer is checking every single program against errors, if he is debugging and then and then he is integrating every single module and forwarding it to testing phase or testing people, the testing team is again checking it and clearing all of the defects, then how come there could be a situation of failure? If we are keeping a separate dedicated phase of testing, if we are keeping a dedicated team for testing, if we are again investing in testing, how can system fail? We need to keep this in mind and make it very clear. Till the product is in our environment, it is definitely going to behave or perform correctly because it is a controlled environment. Any system or any software will only come alive or become productive only when it comes in the customer's environment, or it becomes productive, or it becomes, you can say, it shows how exactly it behaves when we actually put live data, when we actually have live working. Till then, we will not understand the quality of our product. Say for example, you are working on a shopping website and you have launched the website, you have performed all the testing phases, activities, and now you have launched the website. This website is going to have n number of simultaneous users. Some might be working or some might be just going and scrolling it. As it is a dynamic website, it is supposed to accept the user login. It is supposed to perform the phase of authentication. It is supposed to maintain the wish list. It is supposed to maintain the cart, and it is supposed to also perform the billing. If it is having n number of people accessing the same website at the same time, there could be system failure in terms of internet, in terms of network. There could be bandwidth issues. If you're making use of cloud, there could be some issues. If it is taking lot of time to load, it is going to have session expired. There will be issues with the login. So these are definitely going to reflect when it becomes active or when it just comes into practice. Till then, the system is going to remain very, very controlled. With the help of testing, we will also understand and know how software behaves or responds in different conditions or environments. Having bugs in our product can be dangerous and cause harm. Harm can be monetary, harm can be resource destruction, harm can be data loss and misuse, or even human loss. So there are certain examples. There are many cases of disasters which took place because of software failures. Actually, I've tried to collect some of them. Definitely these are the old ones. Now the software industry has gained standards. It has become very, you can say, strong. Now chances of failures are very less, but still history always helps to build a better tomorrow. So this is the history of, you can say, disasters which took place only because of software failure. So China airline Airbus crashed due to a software bug. There was a radiation machine failure where again monetary and money and resources and even there was loss of people's life. There was a failure in a software bank which caused accounts of many customers to be credited with you can say money. As a customer, you might feel happy to read this, but just imagine the loss bank might have suffered. Nissan cars had a failure in their airbag sensory detector. There was a software failure in the airbags sensing, and again accidents took place. they couldn't actually claim life, or they couldn't actually satisfy the standard of, you can say, airbag. Amazon's third-party retailers saw their product price reduced to 1 P, which was again due to software glitch. They suffered very heavy losses in that year. Cosmos Bank cyber attack turned out to be a failure in software, which became a security failure, but it was initially a software failure. So this took place in India, and there are n number of conditions, and you can say n number of situations where losses were losses were because of software only. So these were some of the selected ones. Now let us go through the use of testing or benefits of testing. If you perform the phase of testing very correctly, you will actually try to know whether the developed software is built according to customers' requirements or not. You can also know, is developed software having any defects? You will also get to know, is developed software giving desired outputs or not? Is the product developed meeting industry standards and market standards or not? So these are certain benefits of software testing. Is our product a quality and a scalable product or not? So these are certain benefits of testing. Now there is a question which gets arised in everyone's mind: who performs testing? If developer is debugging the software time to time, he also becomes somewhere or the other the person who is testing the product. So first, a dedicated software team performs testing. Software developers also perform testing directly or indirectly, which is also known as UT, that is unit testing. Project lead or manager can also perform testing. And finally, last but not the least, end users on whom we are completely going to rely. Our product's quality is completely going to depend on how end users approach or how end users use it. So they will perform acceptance testing. Unless and until they accept your software, your product is not going to come into market, or it is not going to get sold. So end users will also perform testing. Thank you.